Good morning, everyone, and welcome to our webinar about the mapping expression in our new editor interface in Next. Let's jump right in. I'm Peter Schmidt. I'm a computational linguist here with AX Semantics, and I'd like to present to you how we can modify data and generally use the thing you know probably from the cockpit as the mapping expression in our Next cockpit. Why do we need a mapping to modify data? I already said so. What does modifying data mean? For example, the data you give the machine can have spelling errors you might want to correct. For example, you could have data values in separate units and things like that, or you might want to combine several data fields to one. That can all be done with the mapping expression when you're editing strings. You can also alter lists in the mapping expression. You can filter them, concatenate them, meaning to make two strings to one. You can sort lists in there, and many other stuff you can do with lists. Or another way to use mapping expressions is you can do calculations. Of course, you can do basic arithmetics, you can add stuff, you can subtract stuff, you can build quota of several data fields, you can sum up lists. And all the stuff you need to do to modify your data to be able to put it into your texts is done in via a mapping expression. Now, for those of you familiar with the cockpit, you had properties there where there was a field mapping expression that, of course, changed in our next version. Now the mapping expression is contained in so-called mapping nodes, and they look like this. You see some ports here and there. Let me tell you how what all these ports do. So first we have a truth port. We are getting a truth value from another node in here with our vertices from other nodes. And this determines if the output that this mapping produces may be used or it shouldn't. Usually, this truth port gets its information from a logic node that also contains logic conditions. Then we have input ports. These little balls here are called ports. The input ports give you the data or are used to put the data into this mapping node. For example, you could input two numbers here as parameter 1 and parameter 2, and you could add up these two numbers and put out the result with this output port into another mapping node or into a variable that can be used in the text. The number of these input ports isn't fixed, so you could have one of them or you could have 10. That's your decision depending on the problem you need to solve. And you just add them as you need them, and they will always get a name like param1 and param2. And you can also rename them. Remember, the data flow in next node is always from left to right. So the input is always to the left, and the output is always to the right. So if when you combine more than one of these kind of nodes, the order of calculation of them is always left to right. They give you a preview of the result. In here, I haven't done any calculations, so it just shows you the green dot. So it's result would be usable. Usually, when I do some calculation inside a node, we will see that later, there will be a preview down here of the result text. It previews texts, or when you're working with lists, it gives you a preview of the list that will be created, that gets put out to the output port. And together with the green dot, or if it's evaluated false, a red dot, you can do a preliminary version of quality control, because you always see what you will get while you're creating the node. And of course, the nodes have names to find them better, but that's a given, I think. Now, the mapping expression is the type of, let me say, code that actually defines how the data will be modified. Where do we put that? No, first, what's the mapping expression? The mapping expression, as I said, it's an instruction language where you have a set of functions that you can apply to your input data. For example, the function add, or the plus sign, will simply add two numbers. Or if you write a text plus another text, it will put those two texts together to make one long text out of it. So you really only are applying operations on the input data. And the result of all the operations you write in a mapping expression will be presented at the output port. And because we are using an input to give a specific output, that operation is called to map, and that's where the name mapping expression comes from. It maps an input to an output. Interestingly, the scope of the operations done in a node are limited to the node. So in the cockpit, usually you had a mapping expression that could get information from wherever it wanted. Every other property was fair game to use. But in the mapping nodes, you usually only use param 1 and param 2 and 3 and 4 and so on. And if you have another mapping node, like mapping 2, for example, that's identical to this one, then their param 1 and 2 are separate param 1 and 2s from this one. Okay, so the data source inside of a mapping node is always only these two. There are no there's no crosstalk between the mapping nodes. And what this enables us to do is you can just copy and paste one of these nodes, and it will work on its own without that, without you having to correct the names of the parameters. You define what gets into these parameters by drawing the vertices from the other nodes into these bubbles here. I will show you that in practice later. It's a bit abstract to explain right now. The mapping expression itself supports nesting of operations. For example, you could add two numbers and divide by a third, all in the same expression. Or you can filter a list and sort it after, all in the same expression. So you don't have to create 7 nodes if you want to do 7 operations. If you wish so, you can all put 7 operations in the same node and just nest the code for that. I will show you that later too. And that later is now. Let's get to a training I prepared. I have uploaded into our next system some data sets. It's pretty much just gibberish, but it's okay for our examples in here. Let's look at the sentences I want to show you. For example, we will do a spelling correction. Spelling of X is now corrected Y. Let's look at what data we have. Here, for example, I have a data field where there's a typo in there. It spells hot god, but of course we want to eat a hot dog. Okay, we can replace the hot god with hot dog in a mapping expression. So let's just do that. And as usual, we have to create data nodes for our data fields. we were working with the data field Tippfehler. It's literally just the word typo. And I will add a input node for, or data node for the Tippfehler. Let's go there in a separate window. Should be quicker. Okay, this is the input I just created, and let's select the wrong data field. You see here, we have the input hot god, and of course we don't want to have hot god as an output here, but hot dog. So what we can do is we put a mapping node in between the input and the output. We need to add these input ports here with clicking add parameter. You see, then I have add param1. I can add as many as I want. As I just told you, now we have 3, but I only want to use 1 right now, so I'll delete 2 again. And I will connect the output of my data node to the input of my mapping node, and the output of my mapping should be the input of my variable that gets put into the text. Need to clean up the variable a bit here. But now you see the output is empty. We want to change that. Here in the mapping expression, first we have to access what gets delivered to param1. We do that with the sharp symbol. You see it already gives us a hint what we can access with that sharp symbol. So I can just click it. And now we just have, we created a simple throughput, hot god. The result of this one will be hot god. So in the text, there will be hot god. But in this mapping expression, now we can apply a replace function to replace god with dog. Let's do that. It's called simply replace. And you see, you get, when you write the parentheses, you get a help what you can do with this function. So raw string is the input. Old sub is the thing I want to replace. There I will be putting dog. And new sub will be the place to put dog, sorry. So dog, god. And we should finish. This means we want to replace it at a maximum of 10 times per. No, sorry, my mistake. Of course, we have to do that as a string. So in like this. You see? Of course, I put it wrong way around. Hot god to dog. We don't want to eat god. And now we have the output hot dog. Okay, and we can put this into our texts now. This is the raw output, phrase 1, I'll call it typo raw. And I can put it in here. Typo raw, typo raw. See, spelling of hot god is now corrected to hot dog. Okay, so that was a string replace. This is some of the most basic functions of the mapping expression and can help you with so many problems regarding your data. I got a question here. In your Zoom interface that you're seeing right now, there is a button F&A or Q&A, depending on which language version you use. Please use this one for questions, and I will answer all your questions after the webinar. Okay, let's take care of another one. X and Y together are X and Y. So this time we want to concatenate two values. And that's also done with a mapping expression. First, let's see what we want to put together. Here we have text 1 and text 2. This is one time hot, second time dog, and another time it's frying, and it's pan another time. So we can put these two data fields together, and once it will create the word hot dog, and another time it will create the word frying pan. And the start is pretty much the same as I did now. I have to add both data fields to my transformer. Data fields text 2. Okay. Okay. Here they are. And now I can create a mapping node that will melt those two together. This time, I have to add two input parameters. The word for putting two texts together is called concatenation, and that's what I will do. But first, I have to add both inputs to my node. And you will see our first node, or our first input is frying, and our second input is pan, and we want to create frying pan. How can we do that? We have the two input parameters. This one is frying, this one is pan, and now I can just write param1 plus param2, and you see the output is frying pan. Same goes for hot dog. When I change the test object, should be this one. Yeah, hot dog. And we can also use a space in between them so that the word is correct. Now we have hot dog and frying pan. And as usual with a phrase variable, the yellow one, we can put that in the text. I will call this one voc concatenation and put it into my text. So X will be text 1, that's this one, and frying and pan together are another container with voc concatenation. With frying and pan together are frying pan. The other one, hot and dog together are hot dog. Okay, so we just glued two strings together. What's next? We can also do the same thing for lists, actually, so that we can glue two lists together. Let's look into the data where we have two lists. For example, I have list 1 and list 2. It's just a list of several colors, and I will make one big color list out of these. As usual, we have to add the lists to our graph. They are all used already because I used this training for the German version of this webinar, but we have to do it, or I need to do it again for English. List 1, add data node. It's already suggesting to me that it's a list. That's correct. Create it. And second one, details, add data node. Another one. Okay. Now we have two new lists. You see, my system created green nodes here because it knows that it's that our input are lists. So it created group variables that I could put in a group container in my sentences. Now we have to put together the lists again. Just as we did with the strings, I create a new mapping node, add two input ports here, and connect my data like this and like this. Now the only difference between this one and the text one is that I don't use the plus sign as the operator, but square brackets. Okay, so two square brackets, we can make a list. So we have a list out of lists. You can see that here. And in our text, it should appear as 1, 5, or 6 element list. Of course, we have to put an output variable here too. Call it group concatenated list. And let's put that in the text too. Add a container as usual. Group concatenated list. And it gives me all entries. Red, green, blue, yellow, white, crimson, one list. And to prove it, we can use a conjunction. This one gets applied once per list, as you might know. So it's red, green, blue, yellow, white, and crimson. If we do the other list, it should change orange, violet, brown, pink, and gold. Okay, so we just melted these two lists together. So we have list operations. We can also filter lists. Yeah, which operates quite the same. I will use just this one with a mapping. I only need one parameter this time because I only want to filter one list. And again, first I have to read the input, param1, brown, pink, gold. And for example, I want to remove the pink of this list. So I can use the function filter. And you see, I give filter and the input list, and then I have to give a function on how to filter. This one is a bit more complicated, but you can read about it in our documentation. Okay, You see, filter parameter with a function if the element, that's what this part means, if the element is unequal pink, it's okay. And you see, pink vanished, brown, gold. And again, we put that in a group variable as an output. Brown, gold. Give it a name so I can find it. Group filtered list. And I can put that in my text too. Group filtered list. Brown, gold. We can also sort those lists. It's pretty much the same thing. And just to show you that we can stagger these, that you can have several of these mapping expressions after each other, I will do another one after the big one I did. So we can use the output of this one in multiple ways. For example, this one is used to put the output of this node into the text, and this one will create a new output for us now. One. And now we can sort it. No. Okay. I'll give you the sort function later, or in the article where this video of this webinar will be posted, because I don't want to waste your time right now with looking it up. Sorry. Okay, but we have another problem left. Let's do some math. So first we added with the plus sign the two strings. If we do that with two numbers, we will calculate it, the addition. Let's do that too. We have two data fields, number 1 and number 2. You see there are numbers in there. We will also add them to the training again. A data node. It's a number, that's right. And the second one, data node create. Okay. Again, let's scroll down. There's the new ones. Okay, and now I can copy the string concatenation that I did earlier here. I just have to remove this this space that we don't need that, but I can remove this structure. I can copy this structure. Sorry. I pressed Control C. So I can reconnect this concatenation operation with my numbers, like this. Okay, and you see he's giving me an error because the operation concatenation with a space is not valid for numbers. But when I remove this, it's only working on numbers, and now it works. And the output works too. You see, 7 plus 3 is 10, and that's what's given. So we can put our calculation in here. I'm creating containers in my text to add my variables. Now, this is the first number. This is the second number. And concatenation 1 was the variable I copied, and this is the 10. When I switch the example, 10 plus 2 is 12. Should be correct. Okay. Same thing we can do for the division of two numbers. I can also copy these nodes. This time I can leave them connected because I want to use the same inputs, but now I have to just change the operator I want to apply. So now we have a division, and 10 divided by 2 is 5. So that's correct also. And we can already put it in here. Same input, different output. Same input, different output. Okay. And we can also do that in lists. We can sum up a complete list of numbers. For that, I have prepared a list of numbers. It's this one. Let's look at it in the data. You see, it's just 23 to 65, 23, 9, whatever. Same thing here. We have to put it into our graph. Here it is. And now the operation we have to implement here is called sum. And that's all that we have to do. And the sum of this list is 45. And we can put it in here. Sum is 45, and the list itself is this one. Sum of the list 91 blah is 45. When I change the data, the sum of this list is 122. That's it. Okay, so these were some examples of how to use a mapping expression, but your fantasy is the limit. Everything you have to, everywhere when you have to modify your data, you have to, when you have to change units, where you have to calculate something, where you have to aggregate something, you can do that in the mapping expression. And usually it looks something like this. You are reading the data, you are changing it, and you are creating an output for it that's prepared linguistically. That's the main part of the mapping expression. I did it so explicitly because we think the mapping expression is one of our most powerful tools in the platform for preparing your input data to put it into the texts. And that's why I dragged that out that long. Okay, last but not least, of course, all these functions that you saw right now in my examples, I know them by head because I'm doing this for a while, but you don't have to guess them. We have a documentation for them and a complete list of what is supported. You can find this list under HTML3 expression docs www.axsemantics.com. Just go to this web address, and then you will find the documentation for all the functions I showed you today and a lot more. Okay, as I said in the beginning, there is a Q&A or F&A part of the Zoom software. Please use it if you have any question, and I'm happy to answer them. I already have a first question from before. The question is, how can I get access to this interface and surface the AX beta? You already have access to it. Go in the platform, log into our cockpit, and when you don't have the AX beta activated, go to the top right where your avatar is. No. And then here with advanced settings, activate this switch. You should all have it, and then you can activate the next beta. You can create trainings in here in the beta, as many as you want. They won't be visible in the old cockpit that you know, and the old projects that you have in the cockpit won't be visible in here, so they are completely separate. Okay. The first question is, the difference between a lookup and this mapping solution is, a lookup is used in a mapping expression. So the mapping solution you can apply if you want to, if you don't only want to look something up. Okay, the lookup, as the name says, is only a kind of lexicon where you can ask for a specific value and translate that to one specific other. And a lookup, for example, can't do math. It can't do list operations and all that stuff. So the lookup actually is one part of the concept of the mapping expression. Okay, there's a more general question. I want to take use of the advantage and ask a general question. How can I add words to the dictionary? To the dictionary of our of the general platform. First, I think you have to activate the lexicon in the advanced settings too. There's a switch lexicon. You have to activate that. Secondly, in the next, under more tools, there's a lexicon button, and here you can add entries. In the old cockpit, it will appear just here in the green ribbon. You're welcome. Okay, I think that should be it. Thank you for listening to me. Thank you for bearing with me in the last part. And I hope we'll see each other in the next webinars. And goodbye.